So I'm conscious that I'm not an infectious diseases person. That's my first disclaimer. My second disclaimer is I'm going to have to run out the door at 6:30 because I've got a train to catch. So my email address is there if you've got any questions for me that we don't pick up in the closing session. Everyone's speaking about the changing face of R&D, the greater amount of open source, open innovation, open data, and AstraZeneca is no different from any other organisation in this respect. And I'm conscious that there's several organisations that we partner with in the audience, including MMV and DNDi. And so this really, this presentation is about how we keep our promises to our collaborators to look after their compounds and ensure that they're used in compliance with what we say we'll do when we start the collaboration in the first place. And the issue that we have within a lot of corporations now is that back in the dark ages, our compound collection was a sort of a single monolithic unit. If there was a compound in there which came up in a screen, we would say, well, is it in the public domain already, or can we not find it in the public domain? And if we couldn't find it in the public domain, then we were fairly safe to assume that that was proprietary to AstraZeneca or GSK or whomsoever. And that's not the case anymore. Our collections are contaminated, if you will, by the efforts of our open innovation activities. And we've got little islands of compounds which are not in the public domain, but we perhaps share with MMV or with DNDi or with Cancer Research UK or Alzheimer's Research or whoever. And with all of these compounds, we have to make sure that we keep our promises. And most of us grew up in the era of material transfer agreements, which, if they had half a dozen compounds in, was quite a lot. And now, of course, the sort of scale of being able to work in assay-ready microtiter plates means that compounds are being shipped around the globe in collaboration with partners to a far greater extent. So what we took the decision is we took the decision that we would keep our compound collection together, so it's a collection of around 1.8 million compounds, and rather than try and put the collaborative compounds to one side or try and put to one side the compounds that we were prepared to share, we would keep everything together, but we would try and really rigorously track the life history of a compound. In terms of what AstraZeneca has been doing over the last few years in open innovation, where we've shared structure with partners out of that 1.8 million compounds, we've shared structure on over 35,000 compounds. So that's 35,000 opportunities to get it wrong by, for example, promising a compound to MMV and then also promising it to Cancer Research UK and not making the two organisations aware of that. So what we came up with is a passport service for compounds, and it does exactly what you'd expect a passport to do. I can look at any compound in our collection and say, what was the originating organisation, where can this asset be tested, and indeed where has it already been tested, and does anybody else have access or have rights over this compound. Like the CDD system, we've heavily borrowed from sort of social media concepts, so this is not some database where you have to fill out a form. Actually, people can use it in sort of real time to record and update their own collaborations. They can add compounds, they can remove them, they can put certain permissions on, and the whole system maintains a permanent audit trail. So if ever we do find ourselves in the embarrassing position where something's gone wrong, we can at least make an attempt at working out where and when and with whom. The way we do that is the architecture is around the asset rights group, and this is the idea is that this will probably be the responsibility of a scientist or a group of scientists within AstraZeneca, and that group sort of defines some broad rules and constraints that dictate whether or not this is a compound that we've shared exclusively with another organisation or we've just provided them with freedom to operate. One of the things that we were really looking for, and the reason that we chose to build a system ourselves, is because it's fully integrated with our testing system. And so the way that we approve or deny test requests, because compounds are restricted for some purpose or another, is also served by this sort of system. And so in this way, a compound is, broadly speaking, it's either locked or not locked. It's owned by AstraZeneca, it's shared ownership, or it's owned by the partner, and those are the sort of permutations and combinations that create the complexity. And so here you can see that there's quite a lot of granularity in the system, so we can work with recording the fact that we've not yet shown the structure to a partner, or we're fully collaborating around it. And it's also very, very quickly searchable, and it can distinguish within seconds between compounds that are part of our open innovation efforts and ones which are exclusively still within AstraZeneca, so they're not found in Compound Passport Service. And this is a kind of a storyboard of how it might be used. So here's an example of a fictitious organization, CollaborX, where AstraZeneca has provided a blinded sample of Series A to the collaborator, and the collaborator has provided a blinded example of Series B. It turns out that whilst we provided the sample, it didn't hold up very well in testing, so there's no need to lock that system within the AZ systems anymore, so it goes back to being not locked, it just goes back into the run-of-the-mill compounds that we can do anything with. But the system still records the fact that CollaborX has had the sample. Turns out that Series B looks rather good, and so CollaborX shares this structure with AstraZeneca. Again, the owner can update the status to show that was when the structure was shared. Actually, things go really, really well, and CollaborX and AstraZeneca start to do some real collaborative research, doing some design, make, test, and analyze, lead optimization together. And so the ownership goes from being owned by CollaborX, which was the other party, to now being shared. And of course, if only the optimization of drug molecules was so simple and straightforward, it turns out that in the fullness of time, Series B did turn out to be disappointing. And so then it becomes locked out to AstraZeneca scientists, and its ownership is handed back to the other party. So you can see from this sort of quick storyboard that potentially tracking compounds within a big organization with multiple collaborators can be very, very complex, which is why we felt we needed a system which actually replicated some of this richness and integrated into the rest of our compound management processes. I've already said that you can view the asset rights very quickly. It's already, I've said about integration into our testing systems. And just the sort of the final thing, it's not a system that we've finished developing. It's based around reusable web services, which means that we can serve that information and call that information from a variety of different systems. We use it on small molecules, but potentially it can be used with any intellectual asset which is worked on in collaboration, in vaccines, cell lines, tissue samples. And again, because it's based on reusable web services, if things like national compound collections and other ways of collaborating in sort of open space, things like CDD become very, very commonplace ways of working, then we've sort of tried to design our system with the sort of capability to interact with those, and again, to call information from those systems and also to serve information to them as well. As I've already mentioned, it tracks around 35,000 assets. An example of the utility is exactly the one that I mentioned, where we had 2 open innovation collaborations that had requested the same chemical series. We were easily able to spot that using this system, and so that we were able to check in with the partners whether or not they were happy to have an asset that was also potentially of interest to another party. Companies reshape, they get into certain strategic areas, they get out of different areas. We needed to divest 4,000 compounds, and we're able actually to search in minutes for what the implications of that would be with the system, something that would have taken days or weeks prior to Compound Passport Service. And then finally, because it maintains an audit trail, we can be quite sure that we can actually monitor whether or not, when we make promises with our collaborators, we actually keep them. It's been a very effective service. because again it's cloud-based and it works on reusable web services, we're actually beginning to open it up to our strategic partners. So Cancer Research UK has access to a cut-down version of the database. And so because we do a lot of work, I'm not, as I say, I'm not an infection person, I'm a cancer person is my background. Because we have a lot of projects with them, it was actually worth opening up the service to them so that they can actually see where there are mistakes in the data, they can see where the exact status of all the different projects and the different compounds that are being trafficked between the two organisations. And in that way, it's certainly enabling our strategy for open innovation and increased collaboration. I've whistled through that to try and get us back onto time, and I'm sure if there's any questions, we can take them at the end.